Okay, this is another MATHCOUNTS national problem. So this was number 8 on the team test. So we have a quadrilateral ABCD is inscribed in a circle with radius of 6. AB, AD are equal, BC, BD are equal. So we want to find the area of the, actually the perimeter of the quadrilateral when we have the area. Okay, so let's kind of start with the visual to see what things are look like. So let's start with circle, and we are told two sides are equal and the other two sides are equal, which is kind of, we do not know how big they are, which is why I'm going to just make a quadrilateral and see if that gives us something. So let's say this is AB, and then we are going to have BAD is the same as this one. So maybe, so I'll go with this is BC. Okay, so it doesn't look like, I'll just go with AD first time. So let's say this is AB and AD, and other two should be equal. So let's assume it's going to be something like this. Okay, so this is A, this is B, C, and D. And we are told this guy and this guy is equal, and then this guy and this guy is equal. So the area of this region is given 60 ABCD, and we want to find the perimeter of this one, and we know the radius as well. So the first things first, we need to relate the radius with the sides of the quadrilateral somehow, so we can kind of use it. So, but another thing we can say easily, you know, we have this chord, then this chord is equal. Like if I want to label the chord AB, like the arc measure, actually, not chord AB, the arc AB, if I say AB, the arc measure of this is, let's say, alpha, and BC is like beta. So this is gonna be alpha, this is alpha, and then BC is beta, and then DC is beta. So which means if I add those, 2 alpha and 2 beta, has to be 360, which will force alpha and beta add up to 180 degrees. So, which is important because if you start from here all the way from A, B, C, this angle right here will be 180, which means if I connect A to C, which will actually divide the entire circle into 3 equal pieces, which is kind of obvious anyway, because you take the AB on this side, AD on this side, BC on this side, DC on this side. So if you kind of didn't say that immediately, you can, I don't know, guess that. So that's reasonable. Anyway, so which means this is going to be my diameter. Okay, so this is my diameter, and then this is 6, and this is 6. If there is a circle, I mean, yeah, if there's a circle and there is a triangle, one side is the diameter, then the angle that facing towards that diameter should be 90 degrees. One reason is this angle called inscribed angle, and opposite arc is gonna be ADC, which is 180 degrees. The half of will be 180 will be 90. So you can just use the same reasoning with this one. So this is also 90. Okay, so we can see that's my diagonal, right? And I want to use the area as well, which I don't know it, but I can maybe like label the two sides. I'm gonna call this is, let's say, X, and then this is Y. If I use the Pythagorean, X squared Y squared is like 12 squared, which is 144. But at the same time, X times Y over 2 is the area of this triangle, but we have the same thing again, so that's twice of that will be 60 from here, so you can cancel those. XY will be 60. So the question is asking X plus Y and double that. So we are looking for 2 times X plus Y. And if I want to find X plus Y, but when I have the square of those and product of those, so maybe I can use the square of binomial. So I can say X plus Y squared is equal to X squared plus Y squared plus 2XY, right? And this is given 144. And then XY was 60. If you double that, so you got 120. So that means 264. So x plus y squared. And if I take a square root, so this is divisible by 4. If I divide this by 4, you got 132. Half will be 66, which means 4 times 66. If I take the square root, so 2 root 66. So I don't want to go ahead and type that because this is what I want. So x plus y is this, so which means we double that number. So 4 root 66. So a couple like kind of takeaways from this problem, I will say, is first thing you start writing everything you are given in the problem on your diagram so you can see how things are related, and that's one thing. The second thing, as soon as you kind of have like 6 and ABC, like label them equal segments, but after you have those, you kind of didn't get anything unless you start writing the equation. So when you do geometry, so you still use a lot algebra. In this case, we kind of two variable because we didn't really know those numbers. But when I start writing some variable for those two sides, I got the Pythagorean, which is an equation gave me, and then I got the area, so which give me another equation. As soon as I have those two, I didn't want to solve for a and b, I mean x and y, because I could have done as well, which is going to be a bit tedious. But then I just ask myself, what should I look for? What I'm looking for in this problem, that's the sum. So, and then I just say we have the square of those variable and product. So we say good job for the square of binomial anyway. So anyway, so I hope that was clear. So I'll see you in the next video.